So far we have created some 6 to 7 basic assemblies which involved rigid, revolute and slider joints. So the majority of the assembly, all the basic assemblies that we have learned so far revolved around these 3 joints only. Now is the time to understand some intermediate assemblies that will involve cylindrical, pin slot and planar joints. So for this, first we are going to cover cylindrical joint using this C-clamp assembly. And here in this particular lecture, we are also going to cover some additional concepts like motion link and contact set. These two concepts, the motion link and contact set, will be covered comprehensively in advanced assembly, but just for the sake of understanding cylindrical joint, we are going to use it here as well. So let's begin. Just start a new design and create a component. Let's name it frame. As you can see in the pre-made assembly, we are having a frame. Then we have an axle which is having a cylindrical joint and which will be rotating on the basis of the frame. And then we have a stopper which is stopping it right over here. So for this, for the frame component, let's start creating a sketch in the vertical plane. Let's make a center rectangle of any dimension. And then again a 2-point rectangle from here to, let's say, somewhere over here. So we are basically creating a frame like structure. Just finish the sketch, select this profile, right click, press pull, make it symmetric. This is too much, let's make it 5 mm only. No, this is also less, let it be 10 only, and create the component. This is your frame component. Here we need a hole to put the axle in. So just create a circle, trace the midpoint from over here, from this edge to anywhere over here. Let's have its dimension as a whole number. Let's make it 10. Finish the sketch and just cut through it. Now we are going to provide thread to this one. Notice we are having this modeled option over here. So when we are clicking on this modeled option, it is actually generating thread. That means if we are not switching this on, this thread like structure is being made, but it's not actually a thread. It's just having a visualization of thread. When we click on modeled, it creates actual thread. So we are taking the thread profile as ISO metric profile, size as 10 mm and designation as M10 into 1.5. If you are aware with the thread nomenclature, you will understand it pretty well, and you can change it from here as well. Let's click on OK, and our first component is ready. Okay, let's give the name to the head assembly. For that we have to save the file. Now activate the head assembly and create a new component. Let's name it axle. So from this face, start creating a circle. We know the dimension was like 10 mm, but if we are seeing over here, it is not snapping anywhere to 10 because we have already created thread. That means the dimension or the diametrical position of the circle that we have created earlier has been changed. So we will simply provide 10 here. Click on OK, finish the sketch, and now you will understand what I'm saying. This whole circle, this blue coloration that is highlighting, this whole circle, that is what we have created right now. but when we are selecting the region, this portion is being left out. This is because we have created thread beforehand. So it's not the issue, just press on control, select this profile also, right click, press pull, let it be up to this one, and let's make it two sides, and let's drag this portion just a little bit, and let's not put it over here because we have to provide stopper as well, and click on OK. So basically we need this stopper in the end of the axle and this handle at the other end. That's why we are not extruding it up to the surface. Now on this particular surface, let's create a rectangle, a center one, and then simply create a 2-point rectangle from here. Finish the sketch, select all these profiles, right click, press pull, just a little bit, and then let's provide fillets here, 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 and let's say here. All right, let's provide fillet here also. And we are good to go. So this created our second component axle, but we need to provide thread on this one also because thread is inside the hole as well. And this thread that we are going to provide should have the same properties as the thread that we have provided in the hole. So we will go to thread. This is this is almost same. You can also click on here to remember the size if you want. Let's make it modeled as well so that we can create actual thread. Perfect. Now activate the head assembly and create a new component. Let's name it stopper. This we are going to create from this face. Let's make a circle just bit bigger than the diameter of the axle. Select this profile, select the inside profile, right click, press pull. Now select this surface and let's provide a taper of let's say 7 degrees. This taper is not here in the pre-made assembly, but just for the sake of proportionality I have made it, and it looks good also. Now invoke the head assembly and all of our components are ready. Now we need to ground one component, so let's ground this frame one and capture the position. Now let's start providing joints. The first joint that we are going to use is between this and the center of the hole, the other side of the center of the hole. So for this we have to select this plus sign over there, but for that when we are dragging the mouse it is not snapping to it. So what we will do, we will press Ctrl in the keyboard and it will snap to it. But the motion here we are going to provide cylindrical. So this is our first cylindrical joint. Let's flip the position. Everything looks good. Again, let's adjust the position just for now. Let it be this much. I think this is sufficient. And click on OK. Now for the next joint, we are using the stopper and the axle. Let's select this face of the stopper and this face of the axle and let's make it rigid and click on OK. Now the assembly is fully complete, but some discrepancies are there. Like when we are moving this, it is not moving properly. It's having a very strange kind of movement, and also we are having overlapping situation. So just revert the position and let's make some adjustments. So here comes the concept of motion link. So a motion link defines rotational and translational relationship between degree of freedom of joints. So in simple words, a motion link defines motion of one particular joint with respect to another. So in case of cylindrical joint, you can see there are two movements. One is translational, that is the slider joint, and one is rotational, that is the revolve joint. And what is a cylindrical joint basically? Cylindrical joint is a mixture of revolve as well as slider joint. So what we will do, we will go to assemble and create motion link. Now for this we will select the cylindrical joint icon over here, and since there is only one joint we are selecting, we will select this link with same joint. Now here you can see the distance is 100 mm and angle is 360 degree. This is saying that for the sliding joint or the sliding motion of this particular component, for every 100 mm 360 degree rotation is there. So what we will do, we will just reduce it. This can be different in your case. You have to have a trial and error method over here. Let it be 50. This looks better. Let's click on OK and let's rotate it. This is much better than earlier. Now let's address the second problem, that is overlapping. Let's revert the position, and one more new concept, that is contact set. Just click on enable contact sets and you can see under the name views you will see contact sets. Just right click and new contact set, and we will select this component and this component. That means they will not overlap anymore. They will have a contact. This is the beauty of contact sets. Click on OK. Now we can move leftwards, but we cannot move rightwards as soon as this contact happens. See, the same thing is here also in the left hand. We cannot move it any further. Let's revert the position. So that's it for our intermediate assembly, the first one, cylindrical joint. In the next lecture, we will learn about pin slot joint. Thank you so much.